Hi guys, in today's session we are going to see about classes in Pega. Okay, so as we know that we have class concepts in OOPS related platforms. Since Pega is based on Java, so in Pega do we have classes concept as well. So we'll see what is class and what is the purpose of it in Pega. So basically, class in general terminology, class is nothing but it's a classification. You can call it as. So classification means you are going to divide the things based on their functionality, based on their behavior, based on their features and all. We are going to segregate and divide them and classify them. So this is nothing but classification, which is nothing but class. Okay. So how humans is one class, you can say. So humans, all humans belongs to humans class. And if you take tiger, lion, and deer, etc., they belongs to animals classification. And plants or trees, okay, all these belongs to trees or whatever the classification they have. So likewise in applications also, or in even the real-time programming languages also, we have classifications. The reason for classes or classification is that they belongs to particular class or classification, so based on their features, as I told you, right? So this is how we are going to classify the thing. So that's nothing but class is nothing but it's a container. Okay, in technical terms it is a container which stores the objects or holds the objects, or you can say it is a container of the objects. What a class contains is objects. Now what is an object? So object is an entity. Okay, object is an entity, so that is basically containing the data and the information in technical terminology. So the data information is in the form of properties or attributes, you can call it as. So let's take an example of a human. Okay, human is a classification or a class, you can think. Okay, okay, human as a class. So humans, we have multiple people, right? It's human means it's a singular word where every person is nothing but it's a human. He's a human being. So either it may be, we have different people like Anil, Akhil, Surya, and all these names, right? So these are different persons who belongs to one classification called humans. Okay, so all the persons, like as I told you, right? Let's take an example of Akhil. Akhil is an object. Okay, so Akhil is a person. So in technical terminology, it is an object. Okay, object one. So let's take this as object one with name Akhil. Age, his age is something like 20, and his gender is male, and his color is white, and his height is 5.9, etc. And let us take an example of other object as well. Object 2. Name something like Surya, age something like 30, gender male, color something like white, height 5.6 or 7 or 8, whatever. Okay, so this is object So now this is one person object, this is another person object. So both these objects belongs to one class called humans class. Human. Okay. So human class. So these are the objects of this particular class, humans class. So this is the class and these are the objects. These two are two objects and this is a class which is a container. Similarly, let us take an example of another class of animals. This is another class where we have multiple objects. Okay, so I will name this object as lion. Okay, let's say lion age is something like 15 years. Okay, something like weight is so and so. And the other animal name is tiger. Age is 10 years, let's see. One or 6 kg. And let's take this as a dog. Age something like 6 years. Its color is something like white. So now I have three objects over here. So this is one object, object 2, object 3. So these three objects, they belong to this particular class called animals class. Okay, so now why we are making this classification is humans class. Humans, they have different behavior and they behave differently, whereas animals, they have different behavior. So here, based on the behavior and based on the features, so here behavior means functional, internal functionality, and features or attributes are called these things. Name is one feature or attribute. This is one. Age is attribute. Gender is attribute. Color is attribute. So all these attributes and functionality of any object related to particular purpose is classified into a different class. So here these behave, I mean the behavior of an animal is different. Animal lion will behave differently rather than humans. So there is a huge classification between the humans and the lions, tigers, and dogs because they are classified into one single unit called as an animals, and all the persons who are there, they are classified into one single classification called as humans. So the behavior of these things, I mean, these things are similar. So these are classified into humans class, whereas the behavior of these things are similar. So they are classified into animals class. So this is how the classification is actually made. So even in terms of application or even in terms of programming languages or oops platforms, so we normally segregate the classes based on the purpose. So the classification is done in such a way that so that particular the object which is related to particular class is nothing but behaving as per the class standards. Okay, so these are the objects and this is the class. So now let us come to the Pega terminology. So basically in Pega we have classes. This is class and these are the objects. This is animals class. These are the objects. So in our terminology, object is nothing but a work object. You can call it as a work object. Work means what? Some whatever the work that is created. So in Pega we have work objects and cases. So whatever the information that is captured across the work object or object is stored within the inside of the object. So this object is ultimately stored in the class. Okay, class can't physically store the objects, but it is a classification. So these two objects will be stored over here. Object 1, object 2 are stored in this particular class. So this particular class has a table mapped at the backend. Okay, so every class is mapped with a database table. Every class has one DB table mapped to it. So it cannot, without the table, class cannot store the instances. Ultimately, there should be a table mapped to the particular classes so that that data, whatever the objects that are there, the objects are created as records in the form of records in the DB tables. So that's the ultimate uh, agenda of this particular class concept. Okay, so I will just clear off. So now, so object, as I told you, right, is a physical object. Whatever the it contains the features which are nothing but attributes and functionality. So features, as we seen, like the properties we have, right? Name, age, gender. So and so person age is this. This age is his color is white. His height is so and so. So the object is nothing but person, and the features are nothing but the attributes. So that is how we are going to segregate. So now, as I told you, class has a table map to it. But before that, we have a classification in Pega. So there are two types of classes in Pega. So one is concrete class, and the other one is abstract. So concrete class is one of the type of the class, okay, that has database table mapped to it at the backend. So every concrete class will have a database table mapped to it. If there is no table map to it, then that will not be a concrete class. So concrete means it exists always. Okay. So it can store the objects data, it can store the records of data in the table. So the ultimately concrete class means it stores the objects in it. Okay, by creating the objects, it will give us the flexibility to create the objects. So objects are stored in this particular concrete classes, and those classes are mapped to the database table at the back. Next, coming to the abstract classes. Abstract class is all about it is just an abstraction. It is used for abstraction. So there is no physical table mapped to it. There is no table at all mapped to the abstract class. So we cannot store the instances. We cannot create the instances or objects in the abstract class. We can't create it. We can't store it. We can do nothing. It is just for the abstraction, or it will act as an extension point for the classes to extend further. Okay, so it cannot store the objects in it. Okay, it acts as a extension for classes to extend. So we can create rules in the abstract classes, but we cannot create the objects, or we cannot create the records, or we cannot map the database table for the abstract class. So that is the difference between the concrete class and the abstract class. Concrete class will have the database table mapped to it, and concrete class should be defined with a key once the table gets created with a primary key. Okay. So let us see how to create the class and what are the existing classes that we can go through. So here, as we see, we have two classes. One is account opening and one is request class. So just I will open the account opening. So click on definition. It will open the class definition. So this is the class. So this is the ID of the class. So normally the name of the class would be starts with the organization name hyphen application name hyphen work hyphen your class name. This is the class or case type name, you can call it as. Okay, so here you can see this is the concrete class. You can select the class type. So now it is disabled because we have already created the database table for this particular class. So basically we have two options here. Okay, one is concrete and another is abstract. So we can see that in the okay, this is also disabled. So just let me create one class. Okay, I'll just create one test class. So class is a part of this admin category. Okay. So I'm just creating my classes test work dash test. So this will be the class name. Okay. So this is the rule set which I'm creating. So now I have created the class successfully. This is the class name. This is the rule set. And now you can see the class type. So abstract and concrete. Okay. So if I select concrete, you can see there is a class group option and there are keys. We can define the keys for this class. And also you can click here for checking the connectivity. Like, if you click on this, it will show. Okay. So right now it's showing error. Okay, because we did not actually created any class for this, right? So just now we have created this. So we have to define the version. Here we have to give the description and usage with relevant reason in the real time, not these things. Okay, so now this is saved. So if you click on test connection, so the class name class work dash text test is mapped to data dot this table. So that means this is the database table and this is the class. So concrete class has a database table mapped to it. If you click on test connection, you can see the table name. Okay. Let's say if you select abstract, you cannot see that option. So you cannot see the test connection option because there is no, in abstract scenario, you can't even map any table. So you don't have any table. You cannot create the objects. You cannot create anything. You can just create only the rules inside this class, but you cannot create or you cannot insert the records. You cannot store the data in the abstract classes. If it is concrete, then you can store the data in that particular class, as we will have a dedicated table. So here you can see this is the table to which this class is mapped. So this is how we are going to define and differentiate between the abstract and the concrete classes. So here you can see keys also. You can define the keys for the class. So key is mandatory for any particular class because there might be a chance of duplication. So we need to define the primary key. Okay. So this is how class works. And we have the class group configuration here. So this part is different where when we discuss about the class groups, I can actually explain you these things, but right away I can't do that. So this is how uh, the class creation of class, and here you can see the inheritance where it will pick from the parent classes. So whatever the class that you define here, so that will act as a parent for this particular test class. Okay. So this is about the classroom, and here you have external mapping where you can map the column name and property name. So this one is for column and property mapping. So this particular class will have a dedicated table as we discussed. So that particular table, if you add some new columns to that particular table, if you want to map those columns with the Pega properties, you can do that over here. So you can add the column name and you can give the property name over here so that whatever the property value that has in this property, so that will be stored in the relevant column in the table. So this is about the class and concrete and abstract differentiation. And coming to the connectivity part, as I already told you, right? So there is a dedicated table for the concrete, but in abstract we don't have that. So when we create a case type, okay, case type. So Pega, what it will do is it will create work class. When we create data type, Pega creates data class. So this is how it works. So we will have two types of classes again. One would be the classification of work related classes, and the other is data related classes. So data classes are nothing but data types. When you add new data type, that is nothing but you are adding a data class or you are creating the data class. If you add a case type, new case type, then it means that you are creating a new work class. So that's how Pega treats. And also the differentiation between the case, the work related classes and data related classes are, so data related classes are used for designing the data model. So if you want to design any data model for any application, in order to make the properties reusable and you have to make the reusable components, you want to build the reusable components across the enterprise or the organization. So in such scenarios, you will do all the rule creations in the data related classes for the reusability. Because if you create your rules in the data related classes, so you can actually configure those rules in the work related classes. Okay, so you can just define the class context, and you can using the reference, page reference or page list reference or whatever, you can consume or you can reuse that data related properties or sections or any rules into work related classes. So there is a reusable possibility to do that. That is the reason normally for the reusability purpose we design the data model by creating data classes. And the other thing is, data classes are used to store the setup type of data. If you want to store, let's say uh, you have countries, okay, you have some 190 countries, you want to store that data, country name, country code, etc. So these kind of data you want to maintain in the application, then you will create the data type as country. So in that countries you will create the properties like, so data type you can create as a countries, or you can create as states also if you want to list out any states. Okay, for this you will create columns like state name, state code, and country name. So these are the three columns. So state name, let's say if you take Karnataka, state code is something like 101, country name is something like IND, and you take Telangana, 102, country India. Similarly, Andhra Pradesh, 103, country India. So this is something like a data which is a setup kind of data, or something like a data storage. Okay, in these scenarios we will create data type which creates a data class. So this is used for storing the data and retrieving the data. Okay, so in these scenarios we are going to use data types to store this kind of data. Like you can store the colleges data, you can use data types to store bulk amounts of data. Okay, which in which new records are inserted into it, or new records will be updated, modified, and retrieved. So all these purposes we use data classes. And coming to work classes, okay, so work classes basically they are dedicated to case types. Whenever you create a case, then Pega will create a work class. So as we see here, right, in the application, we have two case types, the request and account opening. So the same work classes we can see in the, you can see work hyphen. So work is the parent of account opening and request classes. So the purpose of work classes is to maintain the work objects data, to process work. The work related data is stored in these tables. So the request related objects data is stored in the request table, and account opening related objects data is stored in the account opening related class, which has some dedicated table mapped to it. So here the case data and information is stored in the work related classes, whereas the data classes, the data which is something bulk amount of data related to specific purpose. If you want to store accounts data, let's say you have uh, accounts table, you want accounts tables dedicatedly, where account number of the person, account name of the person, and account balance, etc. So you want to maintain in some dedicated table. So in those scenarios you will go with data types. Okay, but in case types it's nothing but work process. Like if you want to create some new object. Okay, so for the case processing, so in those scenarios you will use work classes. So that is the difference between the data related classes and the work related classes. Yeah, so that is about the classes concept among the data and the work related. So how can you define data related classes is, you can see here. Can So your organization name dot dash, sorry, not dot, dash data dash personal details with this. So here you can see address class and personal details class. So these are the part of data classes. And the previous classes which we have seen, account opening and request, those are worker related classes. Okay, so those are the differences between the classes. And yeah, that's it about the classes concept. Yeah, we will come with next topic in the next upcoming session. So guys, if you have any questions or queries, you can post in the comment section. Feel free to reach out to me in the comments with your queries. Thanks for your time and thank you.